Greetings, water and wastewater class. So we're coming back at you for the rest of the semester in a virtual or online format. Many of the PowerPoint slides and everything have already been developed for the class in the past, and we're going to continue to use those. However, I know that there might be some concerns about how we're going to proceed with the class, with class evaluations and things like that. So I'm just going to pull up our previous syllabus. We were looking at having, the exam was going to be originally on March 18th. Obviously, that's not happening. We are now here on March 23rd, and we're getting back into the semester. The symposium that I was going to be attending with several of your classmates, we obviously had that canceled as well. So, this is going to be revised to reflect better dates. However, I want you to know that the exams in here, I don't think it's going to be good for us to do the exams in some sort of timed online format. So the exams that will be associated with this class, as well as the quizzes that will come with this class, those will be things that you'll be able to do on your own. I trust you all will work independently on the exams and the quizzes, and I'm not going to be using these online proctoring things or any of that kind of stuff, or these online timed exams. So you'll be able to do those things at home. Send me what you come up with. The information will be there for you, and so yeah. And then with regards to the lab component, we're going to probably end up emphasizing, you guys working on your existing papers. Maybe I can extend the deadline or something on it, but we'll probably end up doing, you'll submit your initial papers, and then you'll do revisions of those existing papers. And as you do those revisions of those existing papers, we'll be able to use those as your 4 lab grades. There will not be field trips, of course. However, what I'll try my best to do is to integrate the material that would have been on a field trip or would have been in the drinking water lab for your use. So I'll incorporate that part into the lecture, and we'll move on. So still 35% of your grade is related to your lab reports. So the first ones you do are going to be important, and then making the revisions to those will also be important, and those revisions will provide you an opportunity to really improve upon your previous lab report scores. So that's enough for this part. I'm not going to throw any deadlines at you, anything that's unreasonable. So plan on making some time every week to focus on the water class. It doesn't have to be on the Wednesday or Monday 12:35 to 1:50, or Wednesday 12:35 to 4 o'clock type schedule that we operated on before. So good. So as we move forward, there'll be online quizzes. Probably not so much for this first one, because the next thing that we had to do in here was an exam. So rather than an online, you send me the answers to your quiz. The first one we're going to do is that take-home examination. So you'll be able to do those exams from home. And the questions may be a little randomized. I'll give you guys more instructions on that as we go. So any questions? Because if you have any, you can always email me or text me or call me, and I'll provide additional instructions in Blackboard as you need to do that. All right, so I'm going to move into finishing up the last bit of our lecture materials. And in our last bit of our lecture materials, we were covering the eutrophication. So on the eutrophication, we talked a little bit about how eutrophication is often fed by nitrogen and phosphorus in particular. that shows potassium there, but usually that's already abundant enough in the water. These two, N and P, nitrogen and phosphorus, are the two things that often drive eutrophication. And in our part of the country, in our part of the world, which of the two do you think usually is the limiting factor? Meaning it's not there in sufficient quantity to keep the algal blooms going, and that would be phosphorus. So when phosphorus is added, then it's quickly put into use. So nitrogen is usually abundant enough, but sometimes even during an algal bloom, we'll run short on both nitrogen and phosphorus. So both of them can kind of, not be there. But phosphorus in general is sometimes the limiting nutrient for some parts of the Midwest and the Southeast. But there are parts of Kentucky that have a lot of phosphorus already in the ground and in the limestone. So when it rains, just the natural phosphorus going into the system provides the opportunity for these algal blooms. So we know that these algal blooms are a positive feedback loop. So once we put them in there, they stay in there. Some people call this entrainment. They get trapped. They're trapped in the system. The lake becomes self-feeding. We already covered these slides, so some of this should be a review, right? Our natural lakes that were here without humans, things that were made by like glaciers or geological changes, many of them start off in an oligotrophic fashion. These deep, clear, colder lakes, less nutrients usually. Things like Lake Superior are a naturally occurring glacier-made lake that's oligotrophic, but over thousands of years they'll start filling in with nutrients. Lake Erie of the Great Lakes has a mesotrophic designation for a lot of it. It's filled in. It's a shallower lake than the other Great Lakes. And if we don't do anything, once we hit the mesotrophic level, it speeds up. It's kind of like the coronavirus. It's on an exponential curve. So as this takes a long time to get started, but once it gets started, we go from thousands of years to now it takes hundreds of years to go from mesotrophic to eutrophic and hypereutrophic. So that's without humans. When we have man-made or human-made or anthro for human genesis, genic, the making by humans, this eutrophication process doesn't take thousands of years. Instead, it takes decades of years. And things that we release into the environment as humans, the runoff from our streets and the wastewater that might slip in there through failing septic tanks or people illicitly connecting to storm sewers. Some industrial discharges, so some industries, the industrial discharges may have elevated levels of nutrients or food for the organisms. So we have the accidental releases when the bourbon distilleries catch fire. Sometimes fertilizers and pesticides get into the runoff through farms. And then we know that soil and the sediment and erosion, those things carry with them nitrogen and phosphorus from the soil, especially in farmlands. And then we also have 9-point source pollution, which may include some of those things. And stuff that may run off from homes, like failing septic tanks. So this process takes decades. And we know that Lake Reba and Will Green Lake very much are part of that. So when we think of the different lake types, we've got the clearer ones you can see really far down in that have less sediment and also usually less fish, actually. And the types of fish are different. Catfish and things like that can do real well in eutrophic and mesotrophic, but particularly eutrophic waters. Eutrophic waters have more vegetation that can grow even in the sediments. So mesotrophic is kind of in the middle. Eutrophic is the one that's filled in the most. We know that there's a tendency here for the lakes to start off oligotrophic and then become mesotrophic and eventually eutrophic. We call that lake succession. And the trophic state index, for how do we determine if something is eutrophic or not, that's typically done through a trophic state index, and the most common one is Carlson's trophic state index, which he published about in 1977. He did his doctoral dissertation at the University of Minnesota on the trophic state index, and then he ended up being a professor at Kent State University in Northeast Ohio for a long time, and he just retired not too long ago and still stays, Bob Carlson still stays active in the lake monitoring community and runs a lot of volunteer organizations dedicated to measuring the trophic state index, not so much as a health indicator of humans, but more of a kind of a monitoring the condition of our lakes and rivers in the United States. Because some of our lakes are dammed up and behave, some of our rivers are dammed up, and where those dams exist, the rivers act like big lakes. All right, so Carlson's trophic state index, the initial one, the original one, used total phosphorus, chlorophyll A, and sucky depth. And some people have modified it to include nitrogen. So what is sucky depth? Well, there's this disk that's lower down into the water, and the further down you can go into the water, the more likely it is that it's either mesotrophic or oligotrophic. So you can imagine the deep, deep, deep lakes that you can see really far down into the water because the water's really clear, like Lake Superior and parts of the other Great Lakes. They're oligotrophic. At times of the year, Laurel Lake in south central Kentucky, because it doesn't have a lot of nutrients that come into it. There's not a lot of algae. Laurel Lake, at times of the year, Laurel Lake is an oligotrophic lake, and many times of the year it's mesotrophic. So sucky depth is measured as transparency. So very little transparency, 0.3 of a meter. All right, so a meter, it's a yardstick almost 3 feet. All right, so that's a meter. When we're talking about 1/3 of a meter, we're talking about maybe 12 inches or a foot. So if you can only see a foot down in the water, about 30 centimeters down in the water, you're probably in this hypereutrophic condition. If you can see half a meter down, about 1.5 feet, about 18 to 20 inches or so, 18, 19 inches, half a meter, that is still pretty close to hypereutrophic. If you can see 10 meters down the water, almost 30 feet, you know you're in oligotrophic. These numbers are the things that you see for Lake Superior. And occasionally for Laurel Lake, you'll be able to see 18, 20 meters down. So why is that? So during the summer in particular, there's not a lot of algae that grows to block the sunlight. The algae uses the sunlight. It makes the lake harder to see deep down in. So sucky depth is a good proxy, especially in the growing season of the year for the algae, for measuring the productivity of the lake. Carlson's trophic state index is mostly based upon primary productivity, the growth of algae, so things that are photosynthetic. So the higher the chlorophyll A, the more photosynthesis, or the more things doing photosynthesis in the water, the more eutrophic the lake is. And then generally, if there's enough phosphorus, you're going to have enough chlorophyll A. So these three things, any one of them together, is an indicator of trophic state index. Bob Carlson says it's not appropriate to average these. He says if you've got chlorophyll A, then that is the one to use probably. However, this one's a little harder to measure than the other two. It's not that hard to measure, but it's harder to measure than the other two. So sometimes people will measure this or measure this. And they may measure and say, here's what the trophic state index is for this, and here is what it is for this. So I'm going to produce another video here in a second to further finish up our notes for this section. And we will stop the video here, and I will record another one shortly.